Thank you. This morning I want to give you a very quick overview of some work we were asked in the AAPP to do towards the National Climate Risk Assessment last year. And the risk assessment itself, most of you will be aware of, was conducted over 3 years, starting in 2023 with the first pass, 2024 and 25 through to completion in the second pass, and was conducted by the Australian Climate Service, who came to us at the AAPP at the start of the second pass in 24 and said, one of our 11 regions is Antarctica and the Southern Ocean or Southern Territories. Could you help us out? And so, stepping in a little bit late to the process, we said yes, and we took on the task. For those of you who aren't aware, the risk assessment was a really comprehensive exercise in trying to map out the risks and priority hazards for Australia. And the report involved, I won't go through all those numbers, but the report in numbers is very impressive. What I do like is the headline statement, or one of the headline statements, is that no part of Australia, its territories or areas of responsibilities is immune from climate change. The effects and impacts of climate change are already being experienced across Australia's land, oceans and atmosphere, and will be increasingly felt over coming decades. Now, one of the aspects of the report, there are over 15 technical supporting reports, including our Antarctica and climate change technical report, which also form the basis of a large part of the Australian Future Hazards report. And I'd recommend that you read either of those if you want to find out more, because I'll be moving actually at a very fast rate across the highlights of that today. But in doing the risk assessment contribution for the NCRA, we realised there were two aspects that we needed to consider from Antarctica. The first of those was the influence of the Antarctic and Southern Ocean changes actually on Australia, and particularly the national priority hazards. We did this by looking at what in IPCC language are called the climate impact drivers. They're the things that we actually measure and study, like ice sheet mass change, temperatures, sea ice volume, etc. That's not the same as measuring the hazard or the risk, and we'll talk a little bit more about that later. But anyway, we looked at the climate impact drivers, and particularly those that were known to have links to the priority hazards for Australia. And in fact, out of the 10 hazards, really most of them have a connection to high latitude climate. And we concluded, relevant to some of the questions we saw earlier on, that changes in the Antarctic, including Australia's areas of responsibility and the Southern Ocean, will contribute to changes in Australia's weather and coastal sea level over the coming century and beyond. But there's the second aspect which I alluded to as well, and that is not just the impact on Australia, but what are the impacts that changes in Antarctica and Southern Ocean have at high latitude? What are the high latitude specific impacts like on ecosystems and marine resources, driven by temperatures, acidification and other changes, environmental values, and also operational impacts for us, whether it be navigation, transport, sustainment, our infrastructure and our territorial obligations. Given we were entrained fairly late in the process, and the scope of that second category is actually extremely large and involves a very diverse expertise base, we largely pushed that aside and leave that. We made some comments, but that's something that we really need to aspire to incorporate in future assessment. We looked at the main domains, and you'll be hearing, if you haven't already, most of these facts throughout today's talks from the experts. But we looked at the atmosphere, for example. That's the atmosphere that couples high latitude very directly to Australia. And we see that the atmosphere in Antarctica and Southern Ocean is definitely changing. Top left panel, you see Antarctica, East Antarctica, in fact, is often thought to be not responding strongly, but in fact has warmed by 0.3 degrees C per decade since 1950, I believe. We also see evidence of heat waves in Antarctica, and there's a nice cameo study in the report that we did of a 2022 heat wave in East Antarctica. That's the middle panel on the left there, where we saw extreme warming and actually impact on ice shelves and some ice shelf loss. We also know from experience that sudden stratospheric warming events in Antarctica, although relatively rare, are linked to bushfire weather, in southern Australia in particular. And we see all of these changes superimposed on the turnaround in Antarctic ozone, which has had a distinct impact on the weather and climate of the southern hemisphere. In that bottom panel, you can see the past change peaking around 2000 and then the projected recovery through this century in ozone. And there are many challenges for the future. Clouds and radiation are being actively addressed, as you heard from Sonia this morning. We have sparse observations, both in time and space, coarse model data, and our understanding of couplings, particularly the couplings quantitatively that link what we see back to Australia, and the feedbacks is not adequate at this point. Turning to the ice sheet, we've heard from Paul this morning, so I don't need to linger on this, but we have seen losses with global impacts. We also know that there exist these tipping points and instabilities in the ice sheet ocean processes, and potential for progressive irreversible changes and abrupt sea level rise. In that graph, you can see, ignore Greenland in the bottom trace, the middle plume of traces there reaches about 7 millimetres of sea level contribution from Antarctica, most of that from West Antarctica over the period. And you can see around about 2008 an acceleration in the contribution to sea level. When we look at projected change, there's a distinct problem because human attention tends to be on the immediate and short term. Our infrastructure has a longer lifetime, multi-decadal in places, but the long response time of the ice sheets means that today's perturbations will affect the ice sheets for millennia, adding many metres to sea level. And we heard from Paul about this. If we look at sea level rise projections, both in the short term under a range of scenarios, at 2050 we see a range of sea level rise predictions, but by 2100 we start to see this change in response to the forcing. And for the high forcing of SSP 8.5, we can see up to a high-end sea level rise of a metre or so. But these changes, the models don't adequately incorporate the instabilities and abrupt changes that we think may lie within the ice sheet. And so if you in fact incorporate those high-end changes you can't rule out under current knowledge, we see that 2100 could see a 2 metre sea level rise if the instabilities kick in, which increase as we go out forward in time, 5 metres by 2150 and 15 by 2300. These are extreme numbers. The point isn't that they are likely. We actually don't know the likelihood. We can't rule them out. But even under a fairly optimistic 2-degree warming, the multi-millennial commitment without instabilities is 2 to 6 metres. Sea ice, we've heard a little about in the first excellent talk this morning, and we can see that abrupt change in the sea ice extent in that bottom graph there from around 2014 onwards. There's been this rapid decline superimposed on the slow increase in sea ice through the previous decades. The drivers of the decline aren't fully understood. It's an active area of research, and sea ice is critically important. It's a key influence across the cryosphere. It's highly reflective, insulates the ocean. The freeze and melt cycle drives deep saline currents and stratification in the ocean, and it's a key habitat for ecosystems. I won't recount all the impacts of loss, but relevant to today's theme, I want to point out in the blue there that regional weather and climate effects include predicted increases for Australia in warming and precipitation, the frequency and duration of warm and wet extremes. Turning to the Southern Ocean, which we'll hear more about this afternoon, there have been significant Southern Ocean changes. 40% of the anthropogenic CO2 that's gone into the oceans has actually been taken up by the Southern Ocean itself. And that uptake of CO2 has driven acidification, which is having impacts on ecosystems. It's also been warming. Southern Ocean warmed since the middle of last century at least, and the rate of warming has nearly doubled since 1990. And the ocean is becoming fresher and more stratified. In the future, these changes in stratification and circulation have the prospect of changing the uptake or the absorption of heat and carbon in the Southern Ocean, with a feedback accelerating future climate change. And in the report, we talk about also the interaction between the ocean and the ice sheet. We saw a little of this morning, but as the ice of the continental ice melts, It freshens and reduces the formation of deep Antarctic bottom water, allowing the warmer circumpolar deep water, relatively warmer, just a little, to reach the ice sheet more easily, providing a potential feedback loop for the melting of the ice. And we also looked at subantarctic islands. There have been significant changes observed at Macquarie Island, where we've got long-term observations, average annual rainfall increase of 250 millimetres actually. Temperature increases atmospheric and also of the ocean surface waters, and significant sea level rise. Heard Island has probably seen similar change, but we have less monitoring there, but we have seen glaciers have mostly retreated in extent. Changes as we go forward are prospects of a warmer, wetter and windier climate over the remainder of the century. And this is going to have impact on conservation values, but the actual impacts aren't well characterised. And rising sea level changes and weather extremes are going to drive increased pressures on our ability to administer and protect our external territories. To wind up, I want to just come back to the big picture of a risk assessment that incorporates Antarctica and Southern Ocean elements. We certainly hope and would expect that the National Climate Risk Assessment isn't a one-off. The need to actually understand, it's a snapshot, and project and provide information for adaptation in the future is strong. Regardless, we need to be prepared in the Antarctic and Southern Ocean research community so that we can provide even more quantified information for future assessment. So we need to further define the mechanisms that link these things we measure, these climate impact drivers, to actually hazard and risk in Australia. So to move beyond just the CIDs to hazards. And we need to quantify the exposure and vulnerability, particularly for regions of our interest or responsibility down south, be it our stations, be it our ecosystem interests in fisheries or ecological hotspots. And that highlights some gaps that we have in our research. There's obviously the scoping gaps we had this time where we couldn't incorporate the natural environment ecosystems in the time available. We didn't really systematically look at hazards to infrastructure, although we made some comments. And the knowledge gaps we have there are to monitor and understand change. We've heard about that already. There are critical processes and feedbacks that we need to understand, especially those that relate to tipping points and instabilities. And we need improved projections. And that's just not model resolution, but it's the parameterizations of things like clouds. It's also downscaling so that we can look at local assessments and prediction of extremes. Thank you.